Have you ever noticed how water seems to climb a straw after you take a sip? That's what is capillary action of water, one of nature's quietest yet most powerful mysteries. It's that strange moment when water appears to defy gravity, creeping upward as if pulled by invisible strings. You've seen it before, when a paper towel soaks up a spill, or when roots draw moisture deep beneath the soil. It looks simple, but this silent climb once puzzled scientists for centuries. The definition of capillary action begins with two hidden forces: cohesion, where water molecules cling to each other, and adhesion, where they stick to other materials. Imagine a tiny glass tube dipped into water. Nothing dramatic happens at first, but look closer. The water inside rises higher than the surrounding level, as though it's determined to climb. Why? Because the adhesive pull between water and glass beats the downward tug of gravity. Each molecule clings to the wall, pulling the next upward through cohesion, forming that curved surface called a meniscus. And that climb continues, molecule by molecule, until balance is restored. It's a small motion, but a breathtaking one. Gravity loses and water wins. Now imagine a tree, taller than a building, yet with no pump inside it. How does it draw water all the way to its highest leaf? Inside its xylem vessels, microscopic tubes, the same principle of capillary action powers the entire journey. Water enters through the roots, climbs through these tubes, and reaches every leaf that drinks sunlight. Each molecule pulls another, forming an unbroken chain of movement stretching from soil to sky. When the sun evaporates water from leaves, more is pulled upward to replace it, repeating this endless cycle. That's the meaning of capillary action in its purest form, nature's invisible elevator of life. Without it, flowers would wilt, forests would fall silent, and the tallest trees could never rise. It's the same process that keeps cut roses drinking in a vase, or ink flowing through the tip of your pen. Even your morning coffee shows it, as the liquid creeps up the cup's edge before cooling. Pause for a second and think, how can something as soft as water defeat gravity itself? The answer lies in surface tension, that invisible film that holds water molecules tightly together. Surface tension and adhesion join forces, pulling water toward new surfaces while cohesion keeps the flow connected. That balance is the heartbeat of capillary motion. The reason life moves quietly through narrow spaces. If you've seen thin lab tubes measuring blood, they use this same principle for accuracy at tiny scales. The thinner the tube, the stronger the upward pull. Small spaces, big reactions. In sandy soils, water creeps upward through gaps between grains, feeding seeds just beneath the surface. In deserts, plants rely on this motion to sip every drop of nighttime moisture. Nature turns this simple law into a survival strategy, using stillness, not force, to move. From riverbanks to leaves, from paper to skin, capillary action connects worlds unseen. It's invisible, yet essential, a quiet collaboration between molecules, working in perfect harmony. Think about that for a moment. No engines, no wires, just the teamwork of nature's tiniest players. Even tears across your eyes travel this way, keeping them moist without your noticing, or a candle's flame still burning as wax climbs through the wick, drop by drop. So what is capillary action of water really showing us? It shows that strength doesn't always mean power. It can mean connection, persistence, and quiet cooperation. Water, in its gentleness, achieves what brute force never could. It rises. That single fact transforms how we see the world, from forests to fingertips. Even a single blade of grass holds that secret, the courage to rise molecule by molecule. If capillary action stopped tomorrow, trees would wither, pens would fail, and life would stall mid-breath. It's hard to imagine, yet this subtle science sustains nearly everything alive. From blood flowing through capillaries to water traveling in stone, it's the same principle repeating across nature's code. The definition of capillary action isn't just about physics, it's about life's persistence through connection. It whispers the same message across every drop. We move further when we move together. That's the real meaning of capillary action, the art of rising quietly through unity and balance. And what is capillary action of water at its heart? It's water's instinct to climb, to find light, to sustain, to connect everything it touches. A single molecule may seem weak, but together they lift forests, feed flowers, and defy gravity itself. So next time you watch water climb a paper towel, remember, it's not just absorption, it's resilience, it's cooperation, it's life's gentle rebellion against the pull that says, stay down. Capillary action of water reminds us that the smallest connections can lift entire worlds upward. And maybe, in our own lives, that's the quiet lesson nature has been showing us all along, because every rise, every reach begins with a single bond and a will to move upward.